So I think the video is going live, and I'll share my screen now. Okay, so right. So yesterday I had shared two videos, right? Those two videos. One is about the last part of files. So files about it was about reading. So we have already seen how we can write to a text file by fprintf, correct? And in the other videos that I had shared yesterday, those videos are my own video lectures that were recorded. Okay, so it contains the complete details about file operations, and then it also contains self-referential structures. Okay, meaning how a particular structure would be referring to itself, as in uh, one of the example that was mentioned in the video itself was about linked list, and I had shown you what a linked list is, correct? So I had already discussed what a linked list is in this particular CS101 lecture class. Okay, so if you consider a structure, if you consider this particular node, okay, so this one is called a node. Okay, a node contains data and pointer part. Okay, so the data can be anything that you want to store in a structure. Okay, and the structure has a pointer to the same structure itself. Okay, so that is called a self-referential structure. Okay, so it will be like something like this. So you have the data or the content, then the address pointer of the next node, okay, and that will contain the address pointer of the next node, and so on. Okay, so at first, head is a pointer. That is something that you need to understand. Head is a pointer, and head points to this node, which is created using malloc, and then you will actually assign some content, and initially the address pointer of this this node would be null. Okay, which means that it won't be pointing to any pointer in any other node. Okay, and then you will create the next node, okay, using malloc again, and you will assign the content in that, and you will assign the previous node's address part as the address of the current node. Okay, and so on. So let's say it will be something like let me see if I have the code with me. Let me go look for a simple linked list implementation in C. Okay, tutorials point. So the idea is like this. Okay, you don't need to have a key here. Okay, let's imagine that you have a structure. Okay, a structure user defined data type, okay, which is having the name node, okay, and it contains two fields. Okay, it contains data and a pointer to the same structure node. Okay, so which means that you can use a pointer to point to the structure node itself. Okay, so you have a data. So in this example that we are seeing on linked list program in C in the tutorials point, they have two elements, so they have a data and a key. Okay, so let's so it means that if you look at this particular image, right, you will have data, key, and then the next is the pointer. So at first we will create two pointers called head and current to the type struct node, okay, of the type struct node, and it will be assigned the value null. Okay, so the struct node pointers head and current are created and assigned the values null, which means that at first let me make a Excel calc sheet, so that it will be easy for me to explain, and it might also give you some visual hint about what is happening. Yeah, so what I am saying is, we will have a pointer called let's say this is a pointer, okay, called current, okay, and then we will have another pointer called head. Okay, so let me designate it as star head because it's a pointer. Okay, and because it is of struct node type, right, we have to write the struct node star current. Okay, that's the pointer, so let that be actually star current. Okay, so that's the pointer, and at first it has the value, so it has the value, let's say okay, so at first it has the value null. Okay, and head also has the value null. Okay, and then let's go through the program again. So I'm not going to read what is there in print list, I'm not going to read what is there in insert first, I'm not going to look in what is delete first, or I'm not going to look in is list empty or anything. Okay, I'm just going to look and find for the main function. Okay, so definitely there will be a main function, yes. Okay, so here in the main function you can see that a function insert first was called multiple times. So let us take a look at what is insert first. So insert first, as we can see, it takes two parameters, correct? It takes two values. So the actual parameters here are 1 and 10. Okay, so let us take a look at what is insert first. Before that, yeah, I just went through the entire C program, so you should understand that this is quite a long C program. Okay, and in this one what they are implementing is something like a linked list. So this is something that you will learn in your data structures class, but since we have self-referential structures, I want to actually explain it to you how we can actually do it, so that you will get an idea. Okay, so insert first, this is the function insert first that we have. Okay, now one thing that we need to know is the head and the current are global pointers. Okay, they are global pointers. Okay, and now let's take a look at the insert first. Okay, it says first is struct node star link. So it means that we are declaring a variable called a pointer variable called link, which is of type struct node, and we are assigning it some value with this statement. See, the whole statement is actually a declaration and assignment. Okay, or a declaration and definition statement, you can say. Okay, so what happens here is, we have already seen what malloc does, right? You guys have to recollect what malloc is. Okay, so we have already seen what malloc does. Malloc is used for dynamic memory allocation. What it does is, it allocates the amount of memory space as defined in the parameter to malloc, and it returns a void pointer type. Okay, so malloc will return the, in this particular example, it will be size of struct node. And what is the size of a struct node? So that is going to be, this is going to be, let's say 4 bytes. If integer is 4 bytes, it's 4 bytes plus 4 bytes, or if integer is 8 bytes, then it is 8 bytes plus 8 bytes, 16 bytes, plus whatever is the amount of memory storage required for storing this pointer next. Okay, so which means that, let us say that it is going to store 20 bytes, or why do that? Let's write this program. So I'm going to take my Emacs terminal, Emacs editor. Okay, so I'm going to call it as self, and I'm going to write it as into lab 2021 self referential struct.c. Okay, so I've named it as self referential struct.c. Let me write hash include stdio.h hashing, then let's have struct node. So struct node, okay, so a structure is actually defined like this, and if you do not want any global variables at the time of declaration of the structure, or at the time of definition of the structure, you end it with a semicolon without giving the variable var names, right? So that's the idea. So we don't have var names. Now we have integer data, and let's have struct node slash next. Okay, let's have the integer key as well. Okay, now we have an integer int main function, which is going to return 0 to the prompt from where we are running the program. Okay, so int main returns 0, and then we have, let's say, printf. We just want to print the size of integer, and so int is this much, and struct is %d \n. Let's write bytes, and we write size of struct node. Okay, so let me make this full screen and make, yeah, so this is all what I'm doing. I'm just printing the size of integer and printing the size of struct node. Okay. In the lab I have gcc self-referential. Okay, I need to go to 2021, clear, gcc. I hope my screen is visible.
Yes, sir, visible. Yes, sir.
Yeah, as in the fonts are also visible. It's not too small, right? Yeah, now it should be gcc self-referential structure minus o self-referential. Okay, so we have compiled the program. Now I'm going to run the program, and when I ran the program, right, it says integer is 4 bytes and structure is, this particular structure that we have created is 16 bytes, which means that this is taking 4 bytes, this is taking 4 bytes, and this is taking 8 bytes, correct? So that is how you have a total of 16 bytes of storage required in the memory when you declare a structure like this. Now let us go through the program further. Let us also create the necessary things, that is the head and the current. Okay, and let's make it as global variables only. Okay, so we have created the head and the current, and we have created it as global variables. Okay, now let us try to define the function insert first. But before that, let us try to understand what is this insert first doing. So insert first is taking two parameters, the key and the data. Like for instance, it can only take the data also, that is fair enough. Okay, what it does at first is it allocates the memory size. So let us try to do this. Okay, let us do this particular thing. So in our program, let us now comment the first line which we use to print the number of bytes it takes, or let us not keep it there only. Let it be there. Yeah. Now here I am doing the dynamic memory allocation. Here what you need to understand is the first part, right, within the parenthesis, which I have highlighted right now. Is it visible, the highlight?
Yes, sir.
Okay, because yeah. Okay, so the highlighted part, which is from here, okay, from the parenthesis, opening parenthesis, struct node star. Okay, this is called something called typecasting. Okay, this is something called typecasting. Okay, which means that if you have, let us say say sum is 17 and count is 5, both are integer values. Okay, both are integer values, and you want to typecast the operation of sum by count. If you do sum divided by count, then what you will get as answer would be 3. You will not get 3.4 because the operation becomes an integer operation, and the result is, if it is stored in an integer variable, then the result's decimal part would be lost and you will get 3 as the value. Instead, you can also do something called, or you can actually typecast from one variable to another type of variable as well. Okay, so here sum divided by count is typecasted to the type double. Okay, so this is called typecasting. This is something that I haven't told you earlier. Okay, so let us take a look at this particular example. So here, right, this one does something called an
Sir, typecasting you have taught us.
I have taught you?
Yes,
Yes,
sir.
sir.
All right, okay. So yeah, so then yeah, so this typecasting, right, this typecasting struct node star is going to typecast whatever is returned by malloc. Malloc actually returns what you call as a void pointer. Okay, so if we look at man malloc, right, it will say that it will return a void pointer, as you can see here from the documentation. Okay, it takes the size in bytes. Okay, so the size of struct node, right, that is exactly what we had used here in the printf statement, right? So which means that it is taking 16 as the input to this function malloc, and the malloc returns simply a void pointer which need to be typecasted to the particular type of pointer which we want to store it to. The pointer that we want to store it to is called link, and it is of type struct node, which means that we want to typecast the void pointer into a struct node pointer, and this is how we will do the typecasting. So that much is done. Okay, so now let us take a look at the program again. Now what does it do? It accesses the element, okay, that link pointer is pointing to, okay, and accesses the field key. So it accesses the structure or the area that link is pointing to, and accesses the key field, and assigns the value key that was passed as parameter to the insert first function, right? And the same way the data is also stored. Now what happens is the question. So here what we will do is, we will assign the next link to be the head, and head at first is actually null. You should understand that. Okay, so what it does is we will put the we will initialize the pointer next in the structure pointed to by the pointer link. This structure, right, is not having any name. Okay, so the structure that, or the memory area that is pointed to by the pointer link, does not have a name because it was dynamically allocated. Okay, if we do static allocation, then we have a name for that, and since this was allocated dynamically, this can be only pointed to by a pointer, and here the pointer's name is link. Okay, which is of type struct node. Okay, so the link is now pointing to a particular memory area which can store the structure node that contains this much information. Okay, so the structure node can be visualized as something like this. Let me not do it that way. Yeah, something like this, and I'm going to right click on the format cells. Okay, and I'm going to assign it borders. Okay, yeah, now the borders are visible, correct? Yeah, so which means that this will contain the data part, this will contain the key part, and this will contain the next pointer, which is actually star next. Okay, now data, let's say the value that I am passing in this particular function, right, is going to be what is the first 1 and it's in the main function, correct?
1 and 10, sir.
1 and 10, and then 2 and 20, 3 and 40, 3 and 30, right? So 1 and 10. So 10 is the what is it? The data part. So right. So data will be assigned 10. Okay. So you have to understand that this is the result. This particular what do you call node? Okay, which is a struct node, is the result of the malloc function, and you have key is assigned to be 1. Okay, and then what is the next statement that we do there? We assign the next to the head, and the head is null. Okay, which means that this will now point to null, correct? Head is null when the assignment was done. Okay, when the assignment was done, head was none, and then we assign head is equal to link. Okay, so if this is, let's say we have to have in the namespace we have to have something called star link also. So this is the star link, this is the node. Okay, okay, and then what we do is head is equal to link, which means the head which was assigned the value of null earlier is now going to point to, let me call this as B10. You know why I am calling it as B10? Because that is the address in this location, right? So I am going to call it as B10. So head is now pointing to B10. Okay, that is this node. I hope you know why I have mentioned it as B10, because the first cell in a Excel sheet or in a calc sheet is A1, then the next cell is B1,
Yes, sir.
B1, and so on. Okay, so I have it named as B10. So this is how I have, or you can actually visualize to have a particular line between B10 or head and link, as you can probably see here. Head and this link will be visualized, will be connected like this. Now what happens is over here. Now what happens is the insert first function is over. Okay, this much is what the insert first function does. So what it has done is it has inserted the first element 110, and then the insert 220 is called. Okay, and when insert 220 is called, again the insert first function will be called. Okay, so let us take a look at 220. Let us take a look at it over here. So we need to have now this link, right? Let me call it as B11. Okay, because this is link is actually pointing to B11. Okay, now when the program when the first insert 110, right, it finishes execution, insert first 110 finishes execution, right, this link is actually a local variable. Okay, this link is actually a local variable, but the memory location that is allocated with this malloc, since it was not freed using the function free, it will still be accessible in the same program. Okay, which means that although the link, which is a local variable, will get destroyed after the insert first 110 was called. Okay, so that is the reason why I am saying link is B11, and I am going to just delete this. Okay, let's say nothing. All right, so head is now pointing to B11, and now I will have the next node created, which I will call again star link. Okay, and data will be 20, and key will be 2, and next will be initially nothing, and let's see what happens in the program. So link next will be head. Okay, so link next will be whatever that head is pointing to, which means that it will be assigned the value B11. Okay, okay, and then head is equal to link. Okay, so here head is going to have the value of link, and which is actually F11. Okay, so this is now going to be F11. Okay, now what do you understand from this particular thing? Let us try to draw this. Okay, after inserting these two blocks, what happens here is, let me take the draw, or can I put pictures here? May not be a good idea. Okay, I have opened LibreOffice Draw. What I'm going to do is, what happens here is, you will have head. Okay, and then you will have let me write it as 1. Okay, key is equal to 1, data is equal to oh, I'm sorry, this has to be 2, data is equal to 20, and next is equal to star next, right? Star next is equal to B11. Okay, and this head will be, star head will be F11. Okay, and this is F11. Let me make it a little bit bigger. Okay, and I'm going to copy and paste this. Okay, and this is going to be 1, this is going to be 10, and this is going to be null. So let's take a look at what happens. Now what happens here is, let's try to introduce arrows. Okay, oh, this is a funny arrow. Yeah, I think I need this thing. Yeah, right. So it will be linked this way. Okay, do you guys have any doubts regarding this particular insertion so far? It will be linked this way. Okay, and this will be pointing to, let's call it as where do I write a small, yeah, let me write it as null. Okay, this would be pointing to null, and it could be represented like this. Right. Okay, now let us take a look at the next one, which is again insert 330. Okay, now let's go back to insert first again. Okay, so insert first, this is called insert first. Okay, which means that I am inserting as at the first location all the time. Okay, so what happens here is I will now have I'm going to just move it around a little bit, so that it will be better visible. It will be, yeah. All right. Okay, now I'm going to copy this, okay, and paste it again. Okay, and I know that this is where I need to keep it, so I'm going to delete this. Okay, and I'm going to keep it here. Okay, key is going to be 3 and the data is going to be 30. Okay, let's say that, let's go to the LibreOffice Calc. Okay, again with one spacing, if we look at it is J11, so which means that this is the area where we are going to store the value, so which is going to be 30 3, and star next will be F11, correct, and head will be updated to J11. Okay, so and this link will now move to here. Okay, and it will get deleted once the insert first function, insert first 330 is finishes execution. Okay, so let's take a look at that. So you will have J11 now, J11, and F11 it is, F11. Okay, and if I insert the ma'am, class la irukka ma'am, I will call you back. Okay, yeah, so this is how this insertion will happen. So now you can understand that this is what you call as a linked list. If I arrange it in the same line, you can see that it will be like a list of items which are linked together by the pointers. Okay, and here is where we use something called the self-referential structures. Okay, so you can this is how you will insert. You can take a look at delete first. Okay, delete first and the other things as well. Okay, to get a better understanding of what are all done here. So they, after the different insertions are done, it will print the list, correct, and then if it is not empty, it will keep on deleting the data, and after deleting it printed it again, which has nothing, and then it inserts everything again, and it says restored list is again over there. Okay, and so on. So I'm not going through all the things. So this is the idea of what do you call as the self-referential structures. And I want to tell you one more thing in C programming, which I think I have not probably told you, which is the switch statement. Okay, So I think you should definitely go through the videos that I have sent you yesterday, which contains both self-referential structures, of course to not to this level. So please go through this video as well, and this today's class as well. So you have self-referential structures, and then you have about file reading that I have shared with you in yesterday's material. So let's take a look at something called switch statement. Okay, so what is the switch statement? So if I have, let's say calculator dot c. Okay, so I have a calculator function here. Okay, so here, right, let me create a new calculator program. New hash include stdio.h. okay, int main return 0. Let me save it first. Calculator with switch c. Okay, yeah. So now what I am saying is, if I have something, let's say char operation int num1 comma num2, okay, printf enter an expression, okay, you can do it like this, and scanf percentage d percentage c percentage d ampersand num1 comma ampersand operation comma ampersand where is ampersand num2. okay, and then I do if operation equal to plus, right, then add num1 comma num2. if else if operation equal to minus, okay, then I write subtract num1 comma num2. else if operation equal to say star multiply num1 comma num2. else if I have operation, okay, operation else if operation equal to slash, then let's say I'll just write okay, let me not make it complicated with functions like just now. So I'll just write it as int result, okay, or I'll just write it as double result, okay, and I'll just write result is equal to num1 plus num2, okay, and here it will be num1 minus num2, which will be result is equal to, okay, and here it will be result is equal to num1 into num2, and here it will be result equal to num1 divided by num2. Okay, I'm not looking at whether the float values and all of those things are proper or anything, okay, at present. So this is what I wanted to just show you. Else result is equal to, or else printf not a valid operation, okay. we can do one thing. Okay, so I can do it this way. Return 0, printf result of percentage d percentage c percentage d equal to percentage lf, and that is going to be num1 comma num2 comma operation comma num2 comma what is it, result. Okay, so I can write a program like this. Let's see whether this works. Okay, so gcc calculator with switch. Okay, this I have wrongly named it. Okay, it has created a /a.out. Okay, and enter an expression 4 plus 5. So it says 4 plus 5 is 9. If I enter 4c5, it says not a valid operation. If I enter 5 into 5, it says 5 into 5 is 25, right? And if I enter 5, okay, 10 by 2, okay, it gives 5 as the result, and so on. Now this was accomplished using what? An if-else ladder. Okay, this is called an if-else ladder. Okay, the same thing, okay, can be replaced by something called, so I'm going to comment this, comment region. Let me copy this first, and then I'm going to comment it again. Okay, and I'm going to paste it here, and I'm saying switch operation, I think it is like this, case plus, correct? So let's take a look at the example that is given over here. So I have switch grade and case A, something like that. So case A, case plus, then I have result is equal to num1 num2, okay, break case minus, okay, and result is equal to num1 minus num2. This is just another form of writing it. Okay, so the if-else ladder, I would say. So since the case, right, from the entry point it executes as continuous functions, because okay, this case it won't get checked again, you have to put a break. If you don't put a break, then the result is first num1 plus num2, and then so if you don't have a break here, right, then this will be the value of result. Okay, so let me put this break here, case divide star num1 into num2, right, case result is equal to num1 by num2, and break again, and default. There's something called a default case, which I can put like this if I want, which is I'll just copy the printf not a valid operation and return 0. Okay. Yeah, so you can see that I have actually replaced this if-else ladder with something called a switch case statements. Okay, so the if-else ladder I have replaced, and this is called a default case. Okay, which means that if none of these cases match, then this default case will be executed. So let us try and see whether this program will work and produce the same result as the if-else ladder. So I'm going to do, what I'm going to do is I'm just compiling it. Yes, it compiled, and I'm just running it 5 plus 2. Yes, it works. 5C5. Oh, I'm sorry, error out. 56C5. It says not a valid operation and exits. So this is a switch case, and I just wanted to tell you this one as well. So this is similar to the if else ladder, and that's the reason why I did not emphasize on this thing, but you should definitely go through this. Ask me if you have any doubts or anything. That's it, guys. Do you have any doubts, any questions?
No, sir.
Okay. Any concerns about the topics that we have covered so far? Please go through the file operations that is there in the video that I have shared yesterday. Okay, and yesterday I was not in a position to take the class, and that is the reason I have shared the video lectures. Those video lectures are from my recordings only. Okay.
Yes, sir.
Yeah.
Yes, sir.
Sure. Okay, everyone. Thank you. Let us. So which means that you will have everything up till what was covered today, and which is actually essentially the entire topic of entire syllabus of CS101, because we have actually covered, I would say, 100% of the syllabus by today. Okay.
Yes, sir.
Yeah. So rest of the classes that we have, we can use it to learn CS101, as in learn programming in a better way. So let's try to write programs. You can come up with questions. We can write different programs, and have multiple recap, okay, sessions, etc. So good luck for your CS101 CT2. All right. Thank you, everyone.
Thank you, sir.
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 Yeah. So I'll leave the meeting now. Okay.